You're just standing in line for coffee, minding your own business, and someone walks up and asks a perfectly ordinary question. They say, "Hey, where do you live?" You wouldn't even blink, right? It's completely second nature. You'd probably toss out your street name and house number. If they needed the full picture, you'd add your town, your state or province, the zip code, and your country. Boom, done. It's a system we've absolutely perfected to pinpoint exactly where one single human is standing among billions of others. But what if we shift our perspective just a little bit? What if that same person pointed straight up at the sky and asked, "Where does Earth live?" Well, suddenly that question is a whole lot harder to answer. Today, we're going to embark on this incredible journey to find our exact place in the completely incomprehensible scale of the cosmos. We're going to write out your complete cosmic address, step by step, and figure out exactly where we all reside in the universe. So get comfortable, because we are about to take a sprawling trip across space and time, and you don't even need a spaceship.
To really start grasping this massive scale, I want you to try a little thought experiment. Imagine writing a letter to yourself. You fold up the paper, you grab an envelope, you write your name on it, and underneath your name, you write one single lonely word, Earth. Now, if you drop that envelope into some magical interstellar cosmic mailbox, would that letter ever find you? No way, absolutely not. A cosmic postman would look at that envelope and just be hopelessly lost. They'd need vastly more detail. Just like your regular mail carrier needs your street and town to narrow down the right patch of dirt, our cosmic postman needs a lot more information. And here is the truly mind-bending part of this whole thing. Once we finally write Earth on that envelope, we are literally just getting started. The craziest part of your cosmic address isn't actually on this planet at all. It's everything that comes next.
Okay, let's dive into this. We're going to start with the most familiar step on our cosmic envelope, Earth. The first step, our home planet. So, Earth is roughly 12,742 kilometers across. To us, as humans who use our own 2 feet just to walk to the grocery store, that sounds absolutely enormous. It's this immense sphere of rock and water. To put that into perspective, if you jumped in a car right now and tried to drive all the way around Earth's equator at highway speeds, meaning no stopping for gas, no pulling over to sleep, not even grabbing a snack, it would take you roughly 3 solid back-to-back weeks of driving just to do 1 lap. So yeah, to a single person, Earth is a giant, massive world. But context in the universe is everything. Compared to what we're about to put on our cosmic address line, Earth is overwhelmingly tiny. It's basically a microscopic speck, because our planet is just one incredibly small piece of something vastly larger.
And that brings us to our next address line, the completely empty solar system.
Now, you know those colorful classroom posters or the diagrams in science textbooks? They usually show the planets lined up neatly next to each other, practically touching. They kind of look like colorful marbles clustered tightly around a glowing bowling ball. Well, spoiler alert, that is a complete lie. It's an artistic necessity, really. If a publisher actually tried to print a truly to scale map of the solar system on a standard piece of paper, the planets would be microscopic, and the book itself would literally need to be miles wide. The truth is, the real solar system is almost entirely made up of empty space. It is a staggering, enormous amount of absolute nothingness, with just a few tiny specks of matter floating around in the dark.
To really wrap your head around this profound emptiness, let's use an analogy. Imagine shrinking our massive sun down to the size of a standard football. Okay, now place that football right on the goal line of a football field. On that exact scale, Earth wouldn't be a tennis ball or even a marble. It would be a tiny single peppercorn, and it wouldn't be sitting anywhere near the football. You'd have to walk 25 meters down the field just to place that peppercorn down. That is roughly the length of an entire swimming pool of pure empty space between the football and the peppercorn. And what about Neptune, the farthest planet in our neighborhood? Well, on this football scale, Neptune is a single grain of rice sitting 750 meters down the road. That's several whole football fields away from our sun. Imagine standing next to a tiny grain of rice and trying to spot a football almost a kilometer away. These distances are so vast that it takes light itself, the absolute fastest thing in the universe, a little over 8 minutes to leap from the sun to Earth, and about 4.5 hours just to reach that icy little grain of rice we call Neptune.
So the crucial thing we need to do before we leave the solar system is make sure we completely understand a term you've probably heard a million times, the light year. Because it has the word year right there in the name, it sounds like a measurement of time, right? Like days or months or decades. Actually, scratch that. It is absolutely not a measurement of time. A light year is a measurement of distance. It's basically a massive, unimaginable cosmic ruler. See, light moves at a staggering speed of roughly 300,000 kilometers every single second. At that speed, you could orbit the Earth 7.5 times in 1 second. So a light year is simply the distance that light covers when it moves at that top speed for an entire uninterrupted year. It's our ultimate cosmic measuring tape, and it equals roughly 9.46 trillion kilometers. And trust me, we are going to need that measuring tape immediately, because the second we leave the solar system, we hit enormous, mind-numbing stretches of deep darkness. Our absolute nearest stellar neighbor is a small star called Proxima Centauri, and it is 4.2 light-years away. That means even light, traveling at 300,000 kilometers per second, takes over 4 years just to cross the gap between our sun and the very next star. Let's go back to our football analogy for just a second. If the sun is a football sitting in a park, Proxima Centauri is another football sitting 6,500 kilometers away. That's the distance from New York to Paris. Stars are not crowded together. They are these isolated, lonely islands of light, separated by vast, incredibly empty oceans of space.
Let's see how this builds as we zoom out even further into our galactic suburb, the Milky Way. Those vast oceans of empty space and those isolated stars eventually swirl together to form a giant turning spiral containing hundreds of billions of stars.
The Milky Way Galaxy is approximately 100,000 light-years across. Remember our giant ruler? That means a beam of light takes 100,000 years to cross from one side of this glittering disk to the other. But where exactly are we inside this spinning city of stars? You might assume we're right in the thick of it, in the bustling, densely packed center. We aren't. We live in the Orion Spur, about 26,000 light-years from the galactic core. We essentially reside in a quiet, unassuming cosmic suburb, not right downtown, but not completely out in the rural outskirts either. And we are on the move. We orbit the center of the galaxy at a brisk 220 kilometers per second, but the galaxy is so mind-bogglingly huge that taking just one single lap around it takes us 230 million years. To put that massive time frame into perspective, the last time our solar system was in this exact spot in the Milky Way, it was the early Triassic period. The very first tiny dinosaurs were just beginning to appear on a wildly different version of Earth.
Because as massive as the Milky Way is, it turns out it's not alone out there in the dark. And that brilliantly builds to our next massive jump, the giant local group.
The local group is a collection of about 80 known galaxies, all gravitationally bound together and spread across roughly 10 million light-years. One of the most prominent members of this group is our giant neighboring spiral galaxy, Andromeda. Andromeda is 2.5 million light-years away from us. Now, I want you to think deeply about what that actually means for a moment. When you look at Andromeda through a telescope, or even if you manage to spot it as a faint smudge with your naked eye on a very dark, clear night, the light hitting your eye right then left that galaxy 2.5 million years ago. That light traveled across the empty void for 2.5 million years, dodging dust and gas, just to finally reach your pupil today. You aren't seeing Andromeda as it is right now. You are seeing it exactly as it was 2.5 million years in the past. When that specific light left Andromeda, human beings didn't even exist yet. Early hominids were just starting to figure out basic stone tools. That is exactly why astronomers say a telescope is, in a very real way, a time machine. We are literally looking backward in time the further out we gaze.
All right, now we are going to make our biggest jump yet. Let's zoom out again and again and again until the Milky Way, Andromeda, and all those individual galaxies vanish into a vast, sprawling, interconnected cosmic landscape, the Observable Universe bubble.
We have officially reached the observable universe, but we really have to define that word carefully. Observable does not mean this is the entire, complete universe. There is no physical wall out there. There's no brick boundary, no cosmic fence with a glowing neon sign saying nothing beyond this point. It simply represents a horizon of time. The universe is estimated to be 13.8 billion years old. Therefore, the observable universe is just the specific part of the cosmos whose light has had enough time to travel through space and hit our eyes over those 13.8 billion years. It is simply our own personal bubble of visibility.
But here is where the physics get incredibly, wonderfully strange. The observable universe is not 13.8 billion light-years across. Its diameter is actually estimated at a jaw-dropping 93 billion light-years. Wait, how is that even possible if light only had 13.8 billion years to travel? Well, the answer is that the fabric of space itself is expanding. Imagine a little ant walking across a giant rubber sheet right towards you. But as the ant walks, someone is vigorously pulling the edges of that sheet, stretching it out in all directions. The ant is still moving forward, but the space beneath it is being stretched away. It's the same thing here. The light from distant galaxies has been traveling for billions of years, but while it was traveling, the space beneath it was expanding. The original locations of those ancient galaxies have been stretched vastly further away from us over time, which makes our observable bubble a mind-boggling 93 billion light-years wide. And inside this unimaginable sphere, there are perhaps trillions of galaxies.
And that leads us to a major paradigm shift. Does this giant 93 billion light-year bubble mean we are sitting right at the center of the universe? No. But here is the profound truth. You are the center of your observable universe. Because observable relies entirely on the speed of light reaching a specific observer, every single observer in the cosmos is sitting exactly in the middle of their own personal horizon. If an alien is living on a planet in a galaxy billions of light-years away from us, they have their own 93 billion light-year bubble, centered perfectly on their telescope. They see galaxies we can never see, and we see galaxies they can never see. The universe itself has no center, no cosmic throne, but wherever you happen to stand, you are the absolute center of everything you can see.
So if you truly want to write out your complete cosmic address, you stack all these steps together. You start with you. You live on Earth. Earth orbits within the vast, mostly empty space of the solar system. The solar system sits quietly on the Orion spur of the Milky Way Galaxy. The Milky Way is part of that 80-galaxy neighborhood called the local group. And the local group is just one tiny glowing speck within the 93 billion light-year span of the observable universe. That brings our envelope analogy to an absolutely massive 11-level conclusion, just to define exactly where you are sitting, breathing, and listening right now.
When you look at that massive, sprawling address, your original answer to "where do you live" feels totally different now, doesn't it? We are physically tiny. We live on a microscopic rock, orbiting a completely ordinary star, tucked away in a quiet suburb of an incomprehensibly vast space. And yet, there is something profoundly beautiful and empowering about it. Because while human beings are physically small, human curiosity is massive. We are curious enough to look up, to map out this enormous address, to calculate the speed of light, and to trace the very limits of our cosmic view.
But as we finish this explainer, I want to leave you with one final provocative question. What lies beyond the observable? We know our address is just the part we can currently see, but beyond that 93 billion light-year bubble, what is actually out there? Is it infinite? Does it go on forever with more galaxies, more stars, and more planets just like ours? Or is there something else entirely? We simply don't know yet. The darkness between the stars isn't just empty space. It's filled with immense distance, with deep time, and with unanswered mysteries just waiting to be explored. So the next time you step outside on a clear night, look up and remember your real address. Thanks for joining me on this journey, and keep asking questions.